All right, so let's take a look at homework D here. Notice that we are doing a lot of acceleration calculations here. If you have that good habit of actually looking through the assignment before you start it, you notice a lot of acceleration calculations. So number one, the flight speed of a small bottle rocket can vary greatly, depending on how well its powder burns. Suppose a rocket is launched from rest. So what does that mean? That is my initial velocity from rest so that it travels 12.4 meters upward. Okay, that's a displacement. In 2 seconds, didn't finish my sentence. What is the rocket's net acceleration? All right. So, again, things that I know. My delta x. I know my delta t. And I know my velocity. Now, because my initial velocity is 0, I get to do something. And so whenever you look up help on the interwebs, you might see this thing happen. And I want to warn you about what's going on so that you're not confused. So because initial velocity is 0 meters per second, acceleration is equal to 2 delta x divided by delta t squared. All right, so this is the equation that I'm going to use and actually, plug and chug. Why do I need to warn you? It's not as though you'll get a different answer, but when you look at this equation, I don't want you to think that this is some new, unique equation that you've never seen before. I want you to recognize this as one of the kinematics that you have access to. The only difference here is initial velocity is 0. So you're actually not seeing the initial velocity, represented. Say that. So if I go, see if I can get it on my screen. I'm lost right now. Maybe this was a bad idea. Right here. So in your textbook, if I zoom in here, check this out. We have our kinematics, right? Our basic kinematics. If we start from rest, we know that the initial velocity is 0. And so we can use this version, right, instead of this version. That's not to say that the equations are different. It's just that VI is 0. Right? Fair enough? Fair enough? They are this equation right here is the same as this equation. Just that we don't have that VI in there. Because it's 0. It's 0. For instances in which we're actually multiplying by VI, see right here we're actually multiplying by VI. Well, what's anything times 0? 0. So also this delta t disappears as well. Okay? Notice that it's not over here. Okay? So when you start from rest, okay? Now again, why am I warning you of this? Because if you were to go look this up on the interwebs, you might only see this. And you're confused. Like, where's the initial velocity term? This is clearly a different equation than I'm used to, but it's not. Right? It's just that we've already kind of gotten rid of that initial velocity. So heads up there. But once you are not fooled by that, we're in a position where we can plug and chug. So acceleration is equal to, 2. My displacement is 12.4 meters. My time is, 2 seconds? And I need to square it. You guys are going to get so good at these that the only way you're going to miss this on the test is if you forget to square it. Raise your hand if you've ever forgotten to square one of these things on a physics exam. Me, I've done it. And so if the teacher screwed up this way before, you are at risk as well. So be aware, be on guard, double check your work, right? Double check your work. Make sure you don't forget little things like that that will cost you points on the test, right? And that makes me sad. If you know what you're supposed to do and you don't get points, that makes me sad. And then I'm looking at this and I'm seeing 3 sig figs, 2 sig figs. How many sig figs should my answer have? 2. So I'm going to report this with 2 significant figures. Now, I'm not done yet because acceleration is a vector quantity. So it has a magnitude and a direction. Again, this is up, right? So I can write up. That's fine. It's a little bit clunky if you go to do some calculations. I would also accept if you had a big old plus mark, right? Plus sign in the front of there. I would accept that as well because generally speaking, using normal conventions, up is positive. Okay? And so I would accept either. Please don't forget to box out your answer. And we have ourselves an acceleration.